So here we have the function f of x equals square root of x. To get g of x, I applied these transformations step by step. So you can see here the parent function, and now here g of x, which is a transformed function. So the first one is 1/3, which is the vertical stretch of 1/3 about the x-axis. Now, since we're gonna reflect it over the x-axis, you have to change this to a negative sign. So here we have x/3, since it is a horizontal stretch. We have a horizontal stretch of 3 about the y-axis. Here we have x minus 6, since we have a horizontal translation of 6 units to the right. And here we have, at the very end of the function, -2, which is a very vertical translation of 2 units down. Here we can see the domain of g of x. So the domain of g of x goes from 6 to infinity. The range goes from -infinity to -2. And here for f of x, since it is just a radical, square root of x, it's just the domain is 0. It goes from 0 to infinity, and the range is 0 to infinity. So which transformation change from the domain and which transformations change the range? So since there's a reflection in the function about the x-axis, it inverts the range but keeps the same domain. And the horizontal translation changes the domain by moving it to the right. This formula, S equals 15.9 square root of L times F. S is the speed of the vehicle in kilometers per hour, L is the length of the skid marks in meters, and F the coefficient of friction. So here we have 0.80, 0.80, but here we changed the coefficient of friction, so now it's 0.70, so we have less friction. So we can see here, based on the graph, that when the length is 1, the speed of the vehicle is 19. When the length is 5, the speed is 38, and when the length is 10, the speed is approximately 54. State the domain and range of the above function for a real-life context, using your understanding of real-life context of this data to justify these restrictions. The domain will be L greater than 0, since the length of the skid marks cannot be negative or equal to 0. And the range will be S greater than 0, since the speed of the vehicle cannot be negative either. So square root of a function. The graph y equals f of x is shown below. Sketch the graph of the function y equals square root of f of x given the above visual of f of x. By taking a look at f of x, we can see that it is a parabola, and it's been translated to 2 units down and 1 unit to the left. So therefore the function f of x is going to be x plus 1 squared minus 2. And so the function y equals square root of f of x is going to be the square root of x plus 1 minus 2. So we can see this represented here, this graph. You can see this is f of x, the graph of f of x. And here's going to be g of x, square root of f of x. It's going to start here at the vertex of f of x. It has an intersection here. The coordinates are 0, 0,-1, and it also intersects the x-axis 3, 0. For the function below, identify the domains and ranges of y equals f of x and y equals square root of f of x. Clearly label the functions as well as their domains and ranges. Then compare the two functions' domains and ranges. Explain clearly the reasoning behind any changes in the domains and ranges from f of x to square root of f of x. So, yeah, I changed the f of x here. So now it's going to be f of x equals x squared minus 38. So we evaluated the domain. So the domain for this function f of x is going to go from 0 to positive infinity, and the range is going to go from negative 38 to positive infinity. And here, the square root of f of x, we have the domain is going from negative infinity to negative square root of 38. We have union, the union here, the u, is square root of 38 minus, positive infinity. So it goes from square root of 38 to positive infinity. And the range is going to be from 0 to positive infinity. So you can see in the function f of x, the domain is part of all real numbers. But in the square root of f of x, the domain is restricted because you can't take the square root of negative values. On the other hand, the function f of x, the range starts at its minimum to infinity, but in the square root of f of x, the square root transformation changes the range. Solving radical equations graphically. Explain how you can solve the equation graphically, then provide the solution. Algebraic solutions would not be accepted for this question. So I changed the equation, the radical equation, this one, which is 3 square root of 4x plus 25 equals 8. So first you need to separate the equation in two functions. Here I did it, so y is gonna equal 8. It's gonna be the new function. It's gonna have a y intersection in the y-axis. The f of x is gonna be square root of 4x plus 25, which means that for the equation to be right, both functions have to intersect each other. So we can see that they intersect at minus 4.5, 8. We can see also these points. 7, it starts at negative 7, 0. And here you have another intersection at 0, 15. And for the last question, I need to solve this radical equation. So the radical equation is 2x, square root of 2x minus 4 equals to x minus 2. So first we need to square both sides. So you know, to get rid of the square root here, square root sign. So we're gonna get 2x minus 4 equals x minus 2 squared. So here we're gonna factor this to have the same factors here. We're gonna rearrange this to the left, and we're gonna set them equal to 0. It's gonna change the sign to negative. So now we're going to distribute here. And this step we're gonna distribute again. Here we're gonna factor it. Combine the like terms actually. So we have here the factors are square root, x minus 2 and 4 minus x equal to 0. So to get the solutions, the x-intercepts, we have to set them equal to 0. So x minus 2 equal to 0. We have positive 2 and 4 minus x equal to 0. We subtract 1x, so we have 4 and 2. So here we have to verify the solution. So I'm gonna plug in 2. So 2 times 2 is 4. It's gonna be negative 5 minus 4 is gonna be 0, and 2 minus 2 is 0, so it's gonna be square root of 0 equals 0. So this one checks out. And here we have 4 is our solution, our potential solution. So we plug it in. It's gonna be 2 times 4 minus 4 equals 4 minus 2. So we have 8 here. 2 times 4 is 8, minus 4 is gonna be 4. We have square root of 4, then 2. Here we have 4 minus 2 is gonna be 2 equal 2, so 2 equals 2 at the end. This one also checks out.